So, number 20, right? All right. Why is this thing tipped up to the sky? There it goes. All right. So, again, like I was saying yesterday, when I say like a general rule, when I see something, I do something with these. Is that going to be like written in stone? Like it's always going to be the correct way to do things? Maybe not. It's just kind of, it's just like doing jigsaw puzzles. Should you always do the border first? Most of the time that's a good philosophy and a good technique of approaching a puzzle. But in certain puzzles, that may be the hardest part because they may have designed the puzzle where the outside pieces are the hardest pieces, and maybe you start from the inside, work your way out. Like there's different puzzles require different things. When I see quantity squared, though, that's exactly what I think. I think let's take care of that quantity squared, FOIL. Almost 100% of the time. So what's this going to FOIL out to? That'd be sine squared minus 2 sine tangent plus tangent squared. Yes? And again, make sure you know how to FOIL that out. If you have to write it out twice and actually FOIL it and combine like terms, that's fine. I would also look at this one and think, I'm going to kind of do both sides here. Like this isn't going to be one, I'm probably going to do the whole thing on one side. What makes me think that I'm probably going to have to work both sides on this one? Because I got quantity squared over here too, right? So here, can I FOIL first? Or can I distribute that tangent squared first? No. Your Aunt Sally gets angry because you got to take care of exponents before you multiply, right? So we got that tangent squared times the quantity of, and that would be what? Cosine squared minus 2 cosines plus 1. Now, we could distribute here, yes? Before we distribute, though, any ideas? Yeah, probably change that into sine over cosine. And what makes you think of that? Because I'd look at the other side, right? The other side, it's this one's all cosine and tangent, that one's all sine and tangent. So, one of the two I'm going to have to change. I also am looking at the left side. How many terms do I have over here? I have 3. This is a trinomial, right? I have 3 terms. If I distribute this, how many terms am I going to have? Hopefully they're going to match after I do that, right? So what I'm thinking is let's change this into sine and cosine, distribute that, because I know so the cosines are going to cancel. Hopefully that kind of gets me there, right? So let's try that. Sine squared over cosine squared times this, cosine squared minus 2 cosine plus 1. So now we're going to distribute. What's sine squared over cosine squared times cosine squared? That would just be sine squared. That's good. Sine squared over cosine squared times negative 2 cosine. Well, I'm going to have a negative 2 on top. I have a cosine on top, but I have 2 cosines on the bottom, which means one's going to reduce, right? Leaving me with just 1 cosine on the bottom. And I also have a sine squared on top. Yes? Plus sine squared over cosine squared. Now look at what you have. Look at where you're trying to get to. We're almost there, aren't we? The sine squared already matches. The negative 2 matches. What I have here, think of that sine squared as just sine times sine. One of those sines with that cosine is going to make a what? That's going to make that tangent, and I have that leftover sine. So yeah, this turns into negative sine tangent. Does everybody see how this becomes this? So this is really the same thing as negative 2 times sine over cosine. Yes? There's my tangent. And then I have another sine. So I have a 2, a tangent, and an extra sine. So that's what I want. I want the 2, the tangent, and the extra sine. Does that make sense? And then what's sine squared over cosine squared? That's just tangent squared. So basically right from here, this is going to turn into the negative 2 sine tangent. This is going to turn into the tangent squared. And then that's just my sine squared. And they match. Now what made me think, like what were some of the things that I did in here, and why did I do them? Because why I do things are important. Why is it important to talk about the why I did certain things? Like, why did I distribute this side? I could have done some things over here. I could have changed sine over to cosine and done that. What made me think continue working more on this side to distribute? What was the tip that made me think of that? 3 terms, right? Like don't think that's minor. You know, you have to get them to match. So if there's 3 terms over here, I'm going to need 3 terms over there. Now, just because you get it to 3 and 3, does that mean they're going to be perfectly the same? No. But there's a good chance that that's probably going to work out in your favor, right? So go to that and see if that's a way to get there. Look at the number of terms. I've already got 3 here. Well, I've got 3 here, and I know if I distribute, I'm going to have 3. Just see if that works. Like, that's a good approach to doing these. What other ones you got? What do you got? Which one?
Number 15.
15. Did I do that one yesterday? No? 15 says cosine over secant plus tangent. That is somehow supposed to just equal 1 minus sine. Well, I can pretty much look at this one and tell you we're not going to do a whole lot to the right side here. How do I know we're not going to do much to the right side here? There's not much to do, right? So, what could I do to the left side? Any ideas?
I split it up.
You split it up? I like it. Is there anything that made you think split it up?
The fact that there's
2 terms? I needed to get to 2 terms. I like the idea. So this becomes cosine over secant plus cosine over tangent. Is that what you thought? There's a problem there, though. I love the thinking. That's an absolute illegal math trick, though. It works one way and not the other. What I mean is, if you have x plus y over x, is that the same thing as x over x plus y over x? Are these 2 things the same? Yeah, I mean, you have a common denominator here, right? So you could just combine those. Absolutely, that works. If you have a single term in the denominator, you absolutely can split it. Now, compare that with x over x plus y. Can you split this into x over x plus x over y? No. You can't do that because I don't have a common denominator here. I can't go backwards, can I? Like, I can't go from here to here. If this I would have to find a common denominator, which my common denominator would be xy, wouldn't it? So no, you cannot split this way. I love the thinking process of, trying to get two terms with this, but no, that's an actual illegal move, so we can't do that. So any other ideas? What do you got? Yeah, I'm thinking let's go to sine and cosine. And what's leading me there is this is all just sine, isn't it? So really, the goal is let's get it to sine, not just sine and cosine. But it's easy to get to sine and cosine. So there's not much we can do with that cosine, so we'll leave that alone. That secant would be what? 1 over cosine? Plus sine would be sine over cosine? Well, in my denominator, I have a common denominator, don't I? Like if that wasn't there, I already have a common denominator. Can I just add those two fractions? So I get cosine over, and then my common denominator would be cosine, and I'd have 1 plus sine. Nothing fancy. I just had a common denominator here, so I just put them together. Can I now simplify that complex fraction? So if I bring that up and multiply by the reciprocal, what am I going to have? I'm going to have cosine squared, because the cosine times the cosine will be cosine squared, over the 1 plus sine. What did I say our real goal was? Get it all in terms of sine, wasn't it? Because that's the left side. So what can I do with that cosine squared? Even though it doesn't simplify it, I need it to get to sine. What is it in terms of sine? 1 minus sine squared? Now, this next step is kind of the weird thing about these homework assignments that we're actually doing right now, like the 1 through 20, the 21 through, and then the 31 through 36, there's actually a lot of foreshadowing in here. Meaning, the tip we're about to use, you might want to remember this tip because it's going to show up a lot in the near future. Can I reduce this? I can if I factor it. Does that numerator factor? Does 1 minus sine squared factor? What does that factor into? 1 plus sine, 1 minus sine. That's nothing but a difference of two squares. This will factor into 1 plus sine, 1 minus sine. And then you have that over 1 plus sine. Those cancel, and you're done. Now, that idea where this is, that's a thing in our toolbox, right? 1 minus sine squared, that's something we look for. Not only should we be looking for that, we also want to keep in mind that's a difference of two squares, which means it factors into this, which also means this will FOIL back into that, right? So I want you to look at like number 21. Just look at 21. What jumps out at you now? Like what's kind of staring you at the face on number 21? Look at the denominators. Aren't the denominators 1 plus sign and 1 minus sign? If you have denominators like that, and I don't care if you're adding or subtracting, aren't you probably thinking common denominator? And what's your common denominator going to end up being? 1 plus sign, 1 minus sign? Right? Yes, you'll have to figure out what's missing out of, this one's missing out of that one, so you have to distribute it up there, and that one distribute over there. That's the whole numerator. But then the denominator is going to be 1 minus sine squared. And then that could actually be moved to cosine squared, right? So as soon as I see this, 1 plus sign, 1 minus sign, that's what I'm thinking about. I'm thinking, will I be able to get this as like a common denominator, can make those multiply, and then I can convert those into 1 minus sine squared, which means I can convert it to cosine squared. I'm not saying you always need to use that trick, but that's another thing to just be on the lookout for. Does that make sense? All right, what else you got? 23? Sure. Do you want me to do 21? All right, since I kind of got it started. So 21, this was what, cosine? This was cosine. And it's supposed to equal just 2 over cosine. Well, look at the right side. What are we going to have to get it to? Cosine. I got to figure out a way to turn this into cosine. I've got it, don't I? Now, what would my common denominator be? Yep, it'd be one of each of those. What's missing out of this denominator? You guys know what I mean by what's missing out of it? So how do you add fractions? 2/3 plus 3/4. What's your common denominator? 12. Great. What's missing out of this denominator? What do you have to multiply this denominator by? So you got to go like 4 over 4, don't you? That's what I mean. So, you're not going to just move the 2 down here. You got to figure out what you need to multiply by to turn it into that denominator, right? That's exactly what I'm doing here. What's missing out of this? What do I have to multiply to get to here? The 1 minus sign, so I got to distribute through that. So I'd get cosine minus sine cosine. Yes? Plus, and now I got to do this one. What's missing out of this denominator? The 1 plus. So I got to distribute with the cosine, which would give me cosine plus sine cosine. Now what happens? The sine cosines go bye-bye, and what do I have left in my numerator? 2 cosines. Why is that a good thing? I got my 2, right? I needed a 2. I got it. What's left to do here? Turn that into cosine squared and reduce it, right? So that turns into cosine squared. I got a cosine on top, a cosine on the bottom, and that's just 2 over cosine. Because that's in my toolbox, right? 1 minus sine squared. This one here to here.
No, put the sine and cosine up there. Just cancel that out anyways.
Say that one more time.
For the
Here and here.
Yeah.
Now it's basically getting to how big of a step are you making. I need to see your brain working through these. Like, that's just kind of how I have to grade these. There's no other way to grade these. I can't look at the bottom answer. Do you have to have 2 over cosine as your bottom line? No. So everybody's going to be different. I can't just look at your bottom line answer and have a good idea of whether you did it right or wrong. I have to be able to follow through or follow your line of thinking. So, when you start skipping things, I start struggling to follow you. And when I struggle to follow you, I end up taking away little points. So when it comes to whether or not you should show it or not, I would always urge you to err on the side of show more than you think. All right, what else we got? 23? All right. Sine to the 4th power. Oh, that's scary. Over cosine squared. And that is supposed to equal cosine squared minus 2. All right. Anything jump at you? Huh? Difference of two squares. Is sine to the fourth minus 1 a difference of two squares? Yeah. What's that factor into? It'd be sine squared plus 1, sine squared minus 1. Now, I'm going to do something else here. I realize this goes against one of my rules. I look at the right side and I see nothing but cosine, right? So generally thinking, I'm going all cosine here, right? I'm actually going to make a substitution here. I'm going to get rid of that cosine squared. And I'm going to go 1 minus sine squared. Why on earth would I do that? Like, what makes my brain think, hey, even though it goes against what I think I should do to go to cosine, what makes me think, let's do that in this case? Look at the numerator. I'm going to be able to cancel. Now remember, here's that weird little chip. Do these two, obviously the plus doesn't cancel, but do the minus ones cancel? Yes, they do. They're backwards. They cancel, but do they cancel completely away? What do they leave? They leave a negative 1. So those go away. I just get left with a negative 1. So now you're here. Now you have two choices, basically. I mean, yes, you're probably going to distribute that. But now you have two choices. You can turn that sine squared into a cosine squared, or we can go over here and turn this cosine squared into a sine squared. In this case, I'd probably come over here. Why? Save paper. Like, I might as well use this blank space in here and not just keep going farther down. You absolutely could just keep going farther down, but I'm going to change this. What's cosine squared? 1 minus sine squared minus 2. And then I got a negative sine squared. 1 minus 2 is negative 1. Could I have done the same thing here with this sine squared and go, 1 minus cosine squared kind of thing? Yeah. So, you all right, Derek? Shaking your head.
I don't know.
Which part? Like, where did I lose you?
Every single one.
Did I lose you here with the difference of two squares?
I couldn't tell you. If I were to do that by myself, I'd get home, start it, I'd
Okay.
look at it, and be like, I have no idea.
The only thing I can tell you, because I know you have the basic algebra skills to do these. I know you do. I've seen it. This comes down to just two things. Really all it is. You have to know your table so you can recognize the substitutions to make. Like, I have to be able to look at this cosine squared and go, if I want to, I can change this into this. Like, I have to know my toolbox. If you don't know your toolbox, these are almost impossible to do. Remember, like, why am I making you memorize these? Is it because I think you're going to need them for the rest of your life? No. Why do I want you to memorize them? Because without them memorized, these are really hard. Because you just look at it and go, I don't even know what to do. I don't know what I can do. If you have them memorized, things start popping up, don't they? Like, the more you do, the more you learn these, the more you just recognize options of ways to approach these. So that's, like, you have to do those. And then they just come down to practice. Are you guys feeling like the more of these you do, the better you're getting at them? If you're shaking your head no, that's for one reason. You're getting better, but they're also getting harder. So as you're getting better, it doesn't feel like they're getting easier for you because the problems themselves are also getting harder. If you now look back at questions that you've already did, like you look at numbers 5 and 6 and 7 and 8, you go back to those that When we first did them, you started to struggle a little bit. If you look at those now and go, oh, those are cake, then you're absolutely getting better. It just is kind of a weird feeling because as you're getting better, you're also, it's kind of like video games where, yeah, you're getting better at it, but now you're on higher levels and there's just harder levels, so you're still struggling, you know. More practice, more practice. Why do you think, how many assignments this year have I given you where I've made you basically do 1 through 36 all? 2, maybe? Why would I make you do all of these? It's the only way to learn these is to do them. It's the only way. You have to get the practice. Now, I wasn't going to make you try to do 36 in one night. And do you think I'm taking away points for people turning some of these assignments in a day or two late? No. How many of you are done with 1 through 20? Awesome. Turn those in. When you're done, when you're satisfied, I got 1 through 20 right, turn those in. I want these assignments turned in accurate way more than they're on time. If it takes you a couple extra days to get these, take the couple extra days. I want them accurate. I don't necessarily care if they're on time for these. And that goes the same with my virtual kids. Like a couple of them, turned them in and because they were due. Yeah, I sent them back and said, just please get these fixed. Because these are all, half of these are wrong. So, my plan is this. Let's do more of these today. Do more of these, what is today? Today's Wednesday. We're going to do more of these tomorrow in AAA, or tomorrow in class. If you want to come to AAA, we'll do those. I'm going to start Friday by do a couple more if you need them. And then, yeah, I'll, probably do what we were talking about a minute ago. So, all right? Other questions? Which one do you want me to do? 24? All right, so we got sine minus 1 over 1 minus sine squared. Something should be jumping at you right now. Of, ooh, I can do this. What is that one thing that should be like staring you in the face like, hey, look at me, what can I do? Difference of two squares here. What's making you think difference of two squares and factor versus I could also change that to cosine squared? Why are you thinking factor that into the difference of two squares? Because of the numerator. The numerator will cancel, right? I also am looking to the right side going, there's no squareds over there. I'm going to have to cancel, right? There's like, somehow I got to get rid of a squared. So absolutely. Sine minus 1, and then that would factor into 1 plus sine, 1 minus sine. Those are going to cancel, right? But what do they leave? They leave a negative 1. Now, here's where it gets also interesting. You can put that negative 1 anywhere you want. You could put it in the numerator or the denominator. Any ideas of where to put it? Why are you saying the denominator, Laura? Because look at the other side. Yeah, they're probably going to want to distribute it in the bottom, right? So, yeah, I absolutely would be thinking, let's put that negative 1 in the denominator, and now we're basically shooting for negative 1 minus sine. Like 1 over that, right? Like that's probably what I'm shooting for. I know if I wanted to, right here, I could move that negative 1 to the top and put that back to 1 plus sine. I know that. I could make that adjustment if I need to, right? But because of what the denominator looks like over here, it's exactly what we're thinking. Now, I also know I'm going to have to make this a complex fraction, aren't I? And then I'm going to have to simplify the complex fraction. When you start flipping things, could that negative end up being the top real easy? So maybe we'll have to do that. I don't know. So that's going to what? 1 over sine. That's going to be negative 1 over sine minus 1. There's a couple ways to solve complex fractions. Can I just bring this up and flip it right now? You can't do that with a binomial. You would have to find the common denominator, put that together first before you do that. Do you guys remember the other way to simplify complex fractions? What's a common denominator for the whole thing? Sine times by 1. Distribute. What's sine times 1 over sine? 1. Now distribute. What do you get? Negative 1 minus sine. Woohoo! Now, that was a fast way to just simplify that complex fraction, right? Could I have just added those together, found a common denominator, and then flipped it? Yes. I don't care how you're solving these complex fractions. That's just a way of doing that. If you like it, use it. Yeah. Sure. Keep in mind, as I do all of these, Laura asked me for 26. Derek, you might already have 26 done. John, you might already have 26 done. Owen, you might already have 26 done. Go, I already did this one. I got it. If I do it a different way, does that mean yours is wrong? No. No, I'm not saying yours is right, but, you know, just because it's different doesn't necessarily mean it's wrong. You might have done it a different way. So don't get discouraged if I do a problem in a different way that you do. If you really want me to look at yours because it's different than how I did it, let me know. Anything jumping at you? Is there something jumping at me? What? Difference of squares here, right? Now, normally I'd be thinking, let's jump straight to sine over cosine, right? Or sine and cosine. But because I see a difference of 2 squares, let's not do that this time. Let's just use that. What is my common denominator? And I don't, I like to write it only once. If you really want to write it twice, feel free. That becomes a personal thing. If you want to write it twice and go, what's my common denominator? Cosecant minus cotangent, cosecant plus cotangent, right? Here's something I also like to do. Write it once this way. What's another way to write my common denominator? Instead of writing it, again, exactly the same, couldn't I just go cosecant squared minus cotangent squared? Yeah? That's my common denominator, right? What was missing out of this one? The cosecant plus. So times it by 1, and I get cosecant plus. What was missing out of this one? The minus, times it by 1, so I get cosecant minus. Now we combine. What do I have in my numerator? 2 cosecants, right? Which is awesome. What happens to my cotangents? They go away. What do I have in my denominator? Look at your toolbox. I have cosecant squared minus cotangent squared. What is cosecant squared minus cotangent squared? Done! Now, I guarantee you we could have done this in a way different way. Changing into sine and cosine. Make this an ugly complex fraction. Make this an ugly complex fraction. Simplify those. Find the common denominator. Add those together. Change this into 2 over sine, right? We could have done it that way. But what made us think, let's not take that approach for this problem. Let's stay with these ugly reciprocal functions. It was the difference two squares tip, right? That's what, don't just always say rule number 2 or rule number 3 is going to be the best way to do all of them. Like with my tips, like tip number 3 or tip number 4, that's always set in stone. Remember, I didn't say those were step 1, step 2, step 3s. Those were tip 1, try this. Tip 3, like that, try this. They're not going to be written in stone. Each problem's kind of got its own little trick to them sometimes. What else you want? 27 or 30? Well, 27, what do you think you should do? I look at this and I'm thinking different squares, so that's on the top of my head thinking, all right, somehow I got to do that. But I'm also looking at the right side, and before I worry about difference of squares, there's definitely something I got to worry about here. What are you thinking? Foil, 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 foil. Absolutely. So that's going to foil into what? Tangent squared minus 2 tangent secants plus secant squareds. Yes? All right. Now I'm thinking let's go to sine, because that's nothing but sine, right? So tangent squared we become sine over cosine. So sine squared over cosine squared. So minus, the 2 would be here. The tangent would be sine over cosine. The secant would be 1 over cosine, right? Which means I have 2 cosines in the bottom, or cosine squareds. Yes? Plus, what's the secant squared going to become? 1 over cosine squared? I see something that really is nice. Common denominator through the whole thing, don't we? So my common denominator here is cosine squared. Now I could write cosine squared here. And we just combine all of these, right? What else could I have written there instead of cosine squared? 1 minus sine squared. So I like that better. What are you thinking now? When you see a numerator like that, what are you thinking? Factor. You should always be thinking factor. I mean, what do you think of when you see this? You think factor, don't you? Like that's what should pop in your head. So, factor. My numerator factors, my denominator factors. Hopefully things are going to cancel and we're done. So this should be what? Sine minus 1, sine minus 1. This should be 1 plus sine, 1 minus sine. All right, well, we got a problem. It's going to cancel, but it's going to leave that little remnant, right? So where are we going to put the negative 1? Look at where we're going. Look at the other side. Look at where we're at. Look at what we need. The denominators match now, don't they? Do the numerators match? Not quite. What would happen if we distributed the negative? They'd match, wouldn't they? So yeah, just distribute that negative through the numerator. You got it. Make sense? I think Derek's angry at me. He's like giving me evil death eyes, like he's going to kill me. I'm saying that because now it's on film, so I have record that if someone murders me in the next day or two, we all know who it was. Got it? Yeah. 30, absolutely. So we got secant times, I don't know why that's in parentheses, it doesn't need to be. Sine times secant plus 1 That's supposed to equal secant squared minus tangent squared plus tangent all over cosine. Holy yuckiness. All right. Whenever I see something that looks that yucky, no. Can we make it prettier? Like right now, can we make it prettier? Is there anything we have up here that we could make that prettier right now? Isn't secant squared minus tangent squared 1? By just taking this and turning it into 1 plus tangent over cosine, we made that look a whole lot better right now with one simple substitution. Look for that, especially in the nasty looking ones. Look for a simple way to turn things into 1. It makes things way better. Now, I got a tangent. I'm probably thinking sine and cosine, simplify complex fraction. But what are we definitely going to have to do over here? Distribute. I would probably distribute whether you do it before or after you change. I like doing it before. Doesn't really matter. That's going to be sine times 1 over cosine or sine over cosine. And then basically we get what? Sine over cosine squared plus 1 over cosine. Does everybody see how I got to there? Secant's 1 over cosine, so I just times it by sine. It's just sine over cosine. Everybody good so far? Now, I could keep going. I absolutely could keep going. I could find a common denominator. I could put those together. That might be a good approach. But I also got a tangent over here that I'm probably going to have to do something with, right? So what are you thinking? Sine over cosine? So 1 plus sine over cosine over cosine. So what I want to do is I want to bring that cosine up, flip it upside down. I'll bet you $10 if you distribute, you're done. Cool? Try to get as far as you can. See if you can get through 36. We'll try to finish those up tomorrow.